Perfect. All right, so we're going to look at limits of trig functions. Now, I think in tonight's assignment as well, you'll have some stuff with like natural logs and e and things. Okay, we're going to like officially go over natural log and e a little bit later, but I think you should be okay evaluating those things. We'll see. We'll see. Okay. But yeah.
Why do
Yep.
lumberjacks set up?
Say that one more time. So good question. So the question was, do we take a different AP test than the other class? And the answer is like yes and no. So like obviously they're covering more material than us, so they're going to have additional material to their test. But they will have AB questions as well on there. So like they will have I think the same AB questions that you guys have, except some of their AB will be removed and replaced by BC questions. Same thing with like the free response questions. They'll have, I think, 3 of the same free response questions as you guys, and then they'll have 3 that cover material that they cover in that class.
How many questions are on the test?
I forget. I want to say it's... I have to look it up. Yeah, no. I know there's 6 free response questions, and I want to say there's like... I forget how many multiple choice. I'll take a look. I forget. It's like a 3.5 hour test, total.
And there's 6 free response questions?
You get breaks, though, but...
Oh my god.
Okay,
so after the, can we take like a field trip after the AP test to like...
So, I mean, in the past, what I've tried to do is like to meet my students out for lunch, like afterwards or something like that.
Okay, after, okay.
So, traditionally, and I think that should work because I have you guys third block next semester, and that means, well, ideally, right, everyone will be at the test taking it, and so we can all then meet up. And right, you guys can go home, I can come out because then I have fourth block planning, so.
All right, cool. That'll be fun.
So nothing because that gets really boring actually, but we can definitely take a break like the day or two after that. We'll like probably watch Stand and Deliver, which is the only like legitimate math movie that I can show you guys, and then we'll do projects.
We should watch like.
I mean, lightly.
We should watch Wolf of Wall Street.
It's like the kites, the thing.
Stocks and math and stuff.
Moving on. All right.
You have to grasp the line of over.
So we're just going to jump right in here. Okay, we're just going to jump right in. Okay, limits as x approaches 0 of the tangent of x. Okay.
Well, anything multiplied by 0 is 0.
Remember, it's not tangent times x, though. It's tangent of x. So what's our first tool we should attempt here? Direct substitution. Okay, so we're just going to try and evaluate tangent of 0. Okay. Now, for those of you that have difficulty with tangent, right, you like look at tangent, you're like, it's not in a triangle, so what do? Well, we can rewrite it as sine of 0 over cosine of 0, right? Okay. Now, we should know sine of 0. It's not in a triangle, but it's one of the ones we need to know, right? It's on one of the axes. Sine of 0 is what?
Sine of 0 is 0, cosine of 0 is 1.
Right, so we're going to practice that, okay, and sine of 0 is 0, and cosine of 0 is 1. So that means the limit is 0.
See, everything multiplied by 0 is 0.
It's not being multiplied by 0, though, so be careful there. It's not tangent times x, it's tangent of x, okay? Very important, and that's a very common mistake, that's why I want to point that out. Okay, remember guys, tangent is not being multiplied by x. It's tangent of x, okay? Just like when you take the square root of x, okay? It's the same kind of concept. You can't cancel out tangent by dividing it to both sides. You have to do tangent inverse, tangent inverse.
Just divide by tangent. Cancel the tangent.
Interesting. All right. Next one. Here we go. Another one. Limit as x approaches pi of x times the cosine of x. Okay, so now the x is being multiplied by cosine there. Okay, now the x is being multiplied by the cosine. So if this were x approaching 0, it'd be 0, right? But it's not. It's x approaching pi. So again, what's our first tool we should go to? Direct substitution. So we got pi times cosine of pi. By the way, notice I do not continue writing the limit once I actually do the direct substitution, and that is true for you as well. You do not need to continue writing the limit after you've done the direct substitution. If you have simplification to do, like if you still need to simplify this and you're not ready yet to do the direct substitution, you need to continue to write this limit. Okay.
Is that like an AP test thing? Like,
it's correct notation, yeah. And if you like kind of start dropping stuff and being sloppy with your math, then the grader could potentially take away points.
I think on the AP test will be like as non-sloppy as possible.
Well, what I'll say is if you're going to say I'll be not sloppy in the AP test, but now I'll just be sloppy. Well, I would recommend against that. Okay, you want to practice like you're going to play. So you want to write your limits and be real precise and detail oriented now, so that way it's natural later. All right, cosine of pi is what?
0.
All right, so here's how we can think about this. Okay, so there's my axes, right? Okay, pi is right here, okay? And so the coordinate at that point is -1, 0. Cosine is the x-coordinate, so it's -1. So the answer is negative pi. Okay? All right. Another example. We'll do 2 more examples, and I'll have you guys try one on your own. Try 2 on your own. Okay, limit as x approaches pi over 3. Okay, not too shabby. Of sine squared of x.
Do we have to?
Question?
No, I think that's wrong.
So, again, what should be the first thing we try?
Direct
We should try direct substitution and see if we can just, evaluate that. I don't need to put the limit there again. Sorry. Sine squared of pi over 3. So what am I supposed to do first here? Am I supposed to square the pi over 3 and then take the sine of that? Or am I supposed to take sine of pi over 3 and then square it?
Take the sine of pi over 3 and square
We
it.
do the sine of pi over 3 first, okay? When you have something written like this, and maybe you want to write this explicitly in your notes if this is kind of confusing because, notation with trigonometry gets a little bit funky sometimes. This, when you say sine squared of pi over 3, that is saying in, maybe more explicit terms, this. Okay? It's sine of pi over 3, that quantity is squared. Okay? So these two things mean the same thing. And maybe you want to write that in your notes and put a little star next to it if you get that mixed up sometimes, you're not sure. So that means, according to order of operations, we evaluate what is inside the parentheses first. So what is sine of pi over 3?
5.
So, right, no.
Sine of pi over 3 is root 2.
So sine of pi over 3 is root 3 over 2. Okay? And then we're going to square that quantity. Okay? And when you square a fraction, what part of the fraction do you square? All of it, that's right. So root 3 squared is 3, 2 squared is 4. Okay, so 3/4 is going to be your final answer there. Okay? All right. Next one. Last one we're going to do together, and then I'll have you guys try 2 on your own. So limit as theta approaches 5. Right, now that's interesting. There's no pi in that answer. And 5 is not a normal kind of radian measure, but let's just see what happens here. So we've got secant of pi theta over 6. Okay, so limit as theta approaches 5 of the secant of pi times theta over 6. You can say pi theta or theta pi. I mean, it's going to be the same thing, I guess, in this case. But okay, so that means, again, we try direct substitution here, right? The limit as theta approaches 5 of secant of pi theta over 6 is going to be secant of what? 5 pi over 6. Okay, you could say 5 or pi 5 over 6. Pi 5.
Hate that place.
Okay. Or you can say 5 pi over 6, which is probably what we're going to say because that's what we normally write it. Okay. All right. Again, I never really bothered to learn secant and stuff like that. I just make it 1 over cosine, right? Secant is 1 over cosine, 5 pi over 6. Okay. And let's see here, cosine of 5 pi over 6. Well, cosine of pi over 6 is root 3 over 2, so yeah, it's going to be what? Negative root 3 over 2. So it's 1 over negative root 3 over 2. Be careful, don't forget the 1 over part, right?
And that just flips it. So it's
Which
negative
then, right,
2
just
over
makes the reciprocal, so it's negative 2 over root 3.
Oh.
And you don't have to rationalize if you don't want to. Yeah, if you want to rationalize it, let's see, if we multiply,
Root 3 over 3.
negative 2 root 3 over 3. Okay. Oops, sorry, that's off the screen. There it is. Okay. My only, warning is if you choose to rationalize and then you make a mistake in your calculations, guess what? Then you will lose points. Okay, so you may leave it as negative 2 over root 3. Okay, and that is my recommendation to everybody. Okay, when it comes to like a free response question. Okay, actually, here's the interesting thing, right? So in a free response question, you can actually not evaluate trigonometry. You can leave that too. Yeah. So now obviously this would not show up in a free response question because then it's, well, I guess the only work you would have to do there is just show that the 5 goes in and then that's your answer. Okay? But in a free response question you don't even have to evaluate trig. Evaluating trig is considered to be like arithmetic.
Sweet.
We know for all of us, right, that evaluating trig is not quite as easy as evaluating arithmetic, but we're going to get better at it, right? All right, so there's the one I have you guys do, and I'm going to have you guys try too. Okay, so evaluate the limit as x approaches 3 of the cosecant of pi x squared over 4.
You can zoom it out just a little bit, please.
Oh, yeah, sorry. Okay. Okay, so that's one you're going to try, and you're also going to try then the limit as theta approaches pi over 4 of this. That's right. Okay, so I'd like to go ahead, give those two a shot. And yes, they're more difficult than the ones that we did together because I want you guys to stretch yourselves. The sine of 2 theta.
And that's secant of 3.
That's secant of 3 theta, yep. Exactly. I would stick to 1. You don't want to mix those up because of the ratio of the size. It's the same ratio of the size.
thing for spoiling it.
I would, you can, yeah. If you were to be like 1, you say 1 root 2 over 2 for 2 over 2, that's one way to do it, right? Or you can do it like that. That's one way to do it. Right. Okay, that is what I have. And what I would like to say is we're going to have a small quiz tomorrow.
Nice. On what?
Small thing.
Limits.
Is it going to involve this stuff?
Yes. Yes.
Okay.
Yes.
Two. Which is the same as 2.
Involving limits. Okay. Does anyone still need more time? We're still working?
I'm still thinking.
Okay.
Is it pi over 4?
Yeah.
It's 1. Is it pi?
Okay. Anyone have any questions for me? Anyone stuck?
I have a question.
Yeah.
Is this correct? Or a second one?
Yeah, I got negative 1.
Yeah, I think it'd be cool.
I got negative. I like that a lot. Like that. Like that a lot.
And those are the 2 reports. Yes, that. That's okay.
Hey, you wear a holy shirt, dude.
Well, I mean, it's under. Because it's under my left arm, which is the one I don't raise. So, I don't never raise. I mean, I'm sure I do sometimes.
Oh, root 2, when you do the root times root 2, it's root 4, because 2 is the denominator, not, you had a 4 in the denominator.
I just plug everything in.
I know, that's right.
That's literally what I do. I just plug everything in. Yeah. If it was 2 sine theta, then you would multiply axis. Oh my goodness.
Yes.
Remember that video?
Yeah.
The kid running.
Blind
Yeah,
kid
that's
playing
right,
football.
that's not a unit circle, but what can you do?
I can do anything.
I'll let your dreams be dreams.
Not high before?
You see this? Yeah.
Again, not high before, it's not a unit circle, we need to be between 0 and 2 pi. So what can we do to get like an equivalent kind of angle to that 9 pi? Subtract pi over 2.
What?
Subtract 2 pi. Like, add or subtract
Oh, yeah.
pi.
Is today your birthday?
Oh, okay.
That's
Okay, folks, here we go.
That's the Mexican flow.
Let's take a look at this here thing. Okay, so cosecant of pi x squared over 4, the limit is x approaches 3, we just plug the 3 in, right? And we get cosecant of 9 pi over 4, which is not in our unit circle. Oh dear.
It's a coterminal angle.
So right, we need to come up with a coterminal angle. Subtract 2 pi, which was equivalent to subtracting 8 pi over 4, right? So 9 pi over 4 minus 8 pi over 4 is pi over 4. So we want to really just evaluate cosecant of pi over 4. Okay, and that's 1 over the sine of pi over 4. Sine pi over 4 is root 2 over 2, so it's 1 over root 2 over 2, which is then 2 over root 2, and you may stop. Actually, you may stop right there. 1 over root 2 over 2 is fine, okay, as well.
Wait, couldn't you have stopped?
You could have technically stopped like right here, I guess, or right here, actually. Again, if it's a response question. But if it's multiple choice, we need to be comfortable with like simplifying and things too, okay? If this answer, okay, if it's multiple choice and this answer is not shown up in multiple choice, what should we probably do here? So again, let me repeat that. Right, exactly. If you get your answer here, and you're like, you go to the you're like, all right, the answer is 2 over root 2, and you're like, A, no, B, no, C, D, E, no, and you're like, uh-oh, then you need to simplify this by rationalizing, right? That's kind of like the traditional thing to move on to, so rationalize it. Good question, Brent.
Well, on the test,
Assessments and things? Yes. On the AP test, yes.
they won't look at the work, will they?
For multiple choice, no.
So you could technically stop there if you know that it's equal to those two?
Yes, but I would be very careful about like mental mathing your simplification. I would actually do the simplification. Okay. Because yeah. All right. Next one we also plug in. Excuse me. Okay. Tangent of pi over 4, 1. Sine of pi over 2, 1. Cosine of pi over 4, root 2 over 2. Secant of 3 pi over 4. Negative 2 over root 2. And so we get 1 on top and then negative 1 on the bottom, and so negative 1 is your final answer there. Okay, easy peasy lemon squeezy. Limit squeezy. Easy peasy limit squeezy. Okay, next, moving on. I promise you guys that we talk about those special trig limits, and right now I am writing those exact words on my paper, because we're going to talk about special trig limits. Okay? Okay, these you must know. Okay. I will say it again. These you must know. And I'll say it one more time. You must know these. These special trig limits. Okay? Mr. Whitmire, why is this so special? Because if we were to just come across this limit as x approaches 0 of sine of x over x in the wild, first thing you would try is what? Direct substitution. Great, we plug in 0. Sine of 0 is? Everyone's now like 0, alright, 0 over 0. So you get 0 over 0. Okay, that's an indeterminate form, right? So then it's like, alright, now we need to try and manipulate this. Alright, sine. Don't know what to do there. Okay, divide by x. Can't cancel those x's out because it's not sine times x, right? It's sine of x. The x is inside the sine, so you can't get to it, so we're stuck. Okay? If you use your calculator, but by the way, tomorrow calculators won't be allowed on the quiz, okay? But should we use our calculators, we could, kind of like approach this in a table, and it would give us 1, okay? So now, the theory behind this involves, the reason why we can tell that this thing actually goes to 1 is because it involves taking functions that are either always above this or always below this, okay? Like if you were to graph this thing, you can like imagine taking a function that's always above it and always below it. And those two functions, when they approach 0, go to 1. And so therefore we can say this thing also will go to 1. Because, and again, that's the idea. It's called the Squeeze Theorem. And the idea is that if you have a function that's always greater than this thing and a function that's always less than this thing, but if their limits as you approach 0 are both 1, then this thing, because it's going to always be between those two, it must also go to 1 as well. It's called the Squeeze Theorem.
Okay, so if we did that and the functions on either side of it go to different numbers,
then you can't use the Squeeze Theorem, really. But I guess you can say that it would be between those two numbers.
So it would be like the mean of those two.
Not the mean necessarily, no. Not the mean necessarily, but you could say it's between those two for sure.
Oh, okay.
So anyway, that's one of our special trig limits right there. And then there's another one. The limit as x approaches 0. So both of these are limited as x approaches 0. Okay? So if this was like the limit as x approaches 1, you just plug it in. Now, granted, we don't know what sine of 1 is, okay? But this special trig limit is only for the limit as x approaches 0. If this was x approaches pi, you just plug the pi in and evaluate it, right? No problem. But 0 is the special limit, so it's got to be approaching 0. Same deal here. This one has to be approaching 0. This is 1 minus cosine of x over x. Okay, this limit approaches 0. Again, if you try direct substitution, you get 0 over 0, but there's no real easy way to simplify this. Okay, this is not, 1 minus cosine x is not equal to sine of x. Right, some students get confused and are like, oh, 1 minus cosine x equals sine of x. That's not exactly right. It's 1 minus cosine squared is equal to sine squared of x. That's one of those Pythagorean identities if you manipulate it a little bit. Okay, so these two you must know. Okay, we have a quiz tomorrow. You must know these two. Okay, heads up. So let's see how we can utilize these things, or how can we kind of see. So for example, let's say we have this. All right, because obviously if you see the original special trig limit, you know the answer is 1. But this is not that special trig limit, is it? Or not exactly. Right? What does this have? What does my new problem have that the special trig limit does not have? A 3. But can we somehow manipulate this to look like this? And the answer is yes. Okay? Dividing that 3 there, okay, dividing by that 3, what's the same thing as multiplying by what number?
1/3.
1/3. So instead of having sine x over 3x, is that the same thing as saying 1/3 times sine x over x? Isn't that true? Right? Yeah, it is. Yeah, we can if we re-multiply the fractions together, it'll be sine x in the numerator, 3x in the denominator. But now, why is this helpful? Well, because this is just a coefficient, essentially, right? It's just a number, it's just a scalar multiple. We have that property with limits that we can pull that scalar multiple out front, and it'll still be equivalent. Okay, and guess what? What is the limit as x approaches 0 of sine of x over x? 1. So it's 1 times 1/3. So it's just 1/3. That's the answer. Okay, question, Brandon?
I know it probably doesn't matter for some a problem this simple, but if that number, why can't you just simplify it when it's the limit of x approaches 0, 1/3 times sine of x divided by sine?
Like right here, you're saying?
Yeah, why can't you just
You could. I was just trying to make it more kind of explicit that when you have a number times a function, the limit of a number times a function is the same thing as that number times the limit of just a function. Just trying to make more explicit the properties there. But yeah, you could have evaluated right there. That'd be okay. I don't think you'd lose points or anything like that for doing it that way. Yeah. Okay. Let's try another one. Another kind of interesting one here. So we got sine of 4x over x. Okay, so here, yeah, question.
No, I was just going to say, is that where you throw the 4 out front?
So again, let me get to that. So this, first of all, right, we all recognize that this is not our special trig limit, but it's pretty close. This one, though, this new example is a little more challenging, right, because the 4 is not in the denominator, which is easy to take out. It would just become a 1/4 if it was like that. But here the 4 is with the x. And can I just pull this 4 out front?
Well, you have to do something else, but...
Can I just take this 4 out and put it out front like that?
No, just like that.
Yeah, why not? What's the difference here with this 4? Where is it? It's inside of the sign. We can't pull it out. We can't just pull that 4 out. It's not sine times 4x. It's sine of 4x. That 4 is inside the sign, and we can't just easily just pull a 4 out. So how do we fix this? Well, if we can match that 4 that's inside the sign, if we can match that 4 and get a 4 on the bottom, then we'll be able to use our special trig limit. Okay? So how are we going to do that? Well, I'm going to take my sine of 4x over x, and what number do I need in my denominator? 4. So I'm going to multiply this function by 4 over 4. Right? And I can do that because multiplying by 4 over 4 is really just like multiplying by what?
1.
1. And anything you multiply by 1, it's still the same value, right? So I'm not changing the value of my function at all here. But I'm going to be a little bit tricky here. We're going to take... We're going to multiply together the denominators. I left my 4 in the numerator, though, out. And what can I put in my denominator right here? So that's still equivalent to my previous step. What number can go right in here? A 1. Right? Isn't that the same thing? All I did was just move that 4 over here to the x, multiply to the x, but there's still a 1 there, right? So this all multiplies to be the same thing as this, and therefore is the same thing as that, right? The 4's would cancel potentially if I wanted to there and still leave me with a 1. Now this 4 over 1, where can I put that? Outside, in front. So I can say 4 times the limit as x approaches 0 of the sine of 4x over 4x. Now that I have the 4x's matched up, this whole thing is just 1. That's my special trig limit. Since the 4x there matches the 4x there, it's just 4 times 1. So my final answer is 4. Yes.
Okay, correct me if I'm wrong, but
okay.
will the basic
That's my job.
Will the answer be so if we get a question like this on the test and it's like sine 4 of x over x or sine 5 of x over x, will the answer always be 4 or 5 or whatever the number is in that case? Or if it's on the bottom, will the answer just be like the inverse?
The fraction. Right. Now, let me do one more thing here, just kind of like, because this is like I would say the pinnacle of how, kind of tricky that could get. If you have like sine of 2x over 3. So, right, it's going to be 2/3. Oh, sorry, I forgot the x. That's important. Sine of 2x over 3, yeah, it'll end up being 2/3. But again, you want to, we can kind of manipulate this. If we want to kind of convince ourselves it's true. So we can say, like, okay, the over 3, I can make that 1 over 3 there, times sine of 2x over the x. And then I can pull that 1/3 out front, right, and then do, like, 2 over 2 times sine of 2x over x. And sorry, I know I'm kind of going through this pretty quick, but I just want to kind of, like, show here. We're kind of putting together, you can kind of put together both of these things. The two I'll group together there. So it's 1/3 limit as x approaches 0 of 2 over 1 times sine 2x over 2x. And the 2 I'll pull out front, so it's 2/3 of sine of 2x over 2x. So that's, just 2/3 times 1 or 2/3.
So do you want us to, like, show all that work?
No, you don't have to. If you feel comfortable enough with that, then you can just say what it is. That's fine. Yeah, that's okay. Get it wrong though, and there's no work to kind of back it up. But if you get it wrong with the work, then it would be kind of So anyway, but that's the idea. So again, if you guys are trying to figure out here what Ryan's saying, so with the sine, right? Okay, this is like 1/3, right? Essentially, like there's a 1/3 in there. That's in addition to the sine x over x. So the answer ends up being just 1/3. Here, it's 4, kind of like over 1, right? So 4 over 1, 4x. Okay. Now, if I put like a 2 in front there, you want to be careful, right? If I put a 2 in front of the sine, you want to pull that 2 out and then evaluate it. Okay. So be careful trying to use a shortcut there. Make sure you really understand all the ins and outs of it. So again, if I threw a 2 in front here, it would be really then 8, right? Because it would be 2 times that 4 for the. But yeah, it does end up being that 2/3 there. Okay, so just keep that in mind. All right, let's see here. One more. I'm going to have you guys try one. The limit as x approaches 0 of 1 minus cosine squared x all over x plus x cosine x. Okay. So this one doesn't really, I mean, it looks like it's maybe going to be that 1 minus cosine x over x, but it's not really written that way. So what should be our first kind of try? What should be the first thing we try here? Direct substitution. Let's try that. So let's see here. Cosine of 0 is 1. Squared is still 1. So 1 minus 1 is 0 in the numerator. And then 0 plus, well, 0 times anything is going to be 0. So it's 0 over 0. So that's no good. So we have to back up to something else. So, yeah, but it's 0 times, the x is in front there. So it's going to be 0 plus 0 times. So you have to be 0 there. Yeah, there's an x there. So what should be our next kind of step here then? What can we do? What can we do, Ryan?
So 1 minus cosine squared of x, doesn't that equal sine squared of x?
It does equal sine squared, yes. My only concern is I have cosines down here in the bottom. So if I start changing from cosine over to sine, now how am I going to simplify maybe the x plus x cosine x? So that's not wrong thinking, okay, but it's going to lead to a dead end, I'll say. Okay, so what else can we do here? Yeah, factor. Okay, the denominator is pretty easy to see to factor. What can we pull out of the denominator? An x, right? So it's x times, we have 1 plus cosine x. Okay, don't forget, when you pull an x out of an x, you're left with 1, okay, not 0. It doesn't go away. What about the numerator? Is that factor?
Yeah, it's just like x squared minus...
It's a difference of squares. It's 1 minus cosine x times 1 plus cosine x. Things cancel. Okay, the 1 plus cosine x's cancel. And we're left with the limit as x approaches 0 of 1 minus cosine x over x.
Nice.
Okay, so we try direct substitution now, right?
It's just a special...
It's just a special trig limit, that's right. So this equals 0. Okay. So that's why it's so important to know those special trig limits, right? Because you don't want to waste your time trying to find something that you can't find without using that special trig limit. Okay, questions on any of that? All right, we're going to do one more here, and this is like a bit of a like a right turn, or it's a bit of a turn here, kind of in preparation for tomorrow's quiz to make sure we're okay with this stuff. So I'm going to give you guys a little piecewise function here.
Rut-row spaghettios.
Rut-row spaghettios. X squared plus 1, yep. Mm-hmm.
Should the bottom one be x is greater than or equal to 4?
No, actually, this is what that's actually what I meant to write the way it is there. And I'll zoom in here because I know it's kind of weensy. There it is. Okay, so all I want you to do is to find those limits, to evaluate those limits for that piecewise function there. So go ahead and evaluate that. I guess I should too. Okay.
The first one? I got 1 for the first one. I think it's D and E for the second one. Yeah, it's D and E for the second
Yes.
one.
Number 2 is incorrect.
That one does actually exist.
Is there 5 most of the numbers?
Mm-hmm.
Oh, do you not, for that one, do you not use this one?
Oh, exactly.
Okay.
Because we're approaching.
Oh, yeah, true.
Again, that's why I wrote that one that way. Or that's why that's why that one's written that way.
Which one's supposed to be this?
Alright, time to first and second one.
I have to study the words, the vocab words.
I think I know the other words.
Which one did you use to use the expert plus 1?
I use expert plus 1 and I use a negative plus 9.
Do we have a quiz for our fourth yet, or are we just going to?
Today's review day. Tomorrow's test.
Okay, so Anna, numero uno. What'd you get? You got 1? Good job, that's right. I know.
Of course he's going to say he's going to
Okay, how'd you get that, Anna? What'd you do?
I kind of just plugged in 0 for the first part, 0 for 1.
So you plug 0 into this one,
Yeah.
okay?
I plugged in 0 for the second one at the end.
Good, because we have to approach from both sides, right? And so plugging into the top one is approaching 0 from the, what side would that be?
Left.
Left hand or right hand? And for x values less than 0, so left would be to the left, from the left, and then x values to the right of 0 would be to this one. And the numbers are the same. They both go to 1, so 1 is the answer. Great job. Okay, next. Ryan, numero dos.
5.
5. Okay, how'd you get that?
So I plugged it into the second one and
Okay.
the fourth one.
And the fourth, why not this one? That's when x is 2.
Because
3.
we're approaching it, not.
Right. Limits, we approach things. We don't actually get there. So we only use this top, x squared plus 1 and this one because that is approaching the 2 from the left and from the right. And so yes, they both approach 5. We ignore this one that at 2 it's 3. Ignore it. We don't care what happens at 2. What happens is we approach 2 from the left and from the right. Last one, we'll go to Christian.
That does not exist.
Okay, how'd you get that?
When I was attempting to plug in 4 for the third and fourth, or fourth and fifth one, there's 2 different numbers.
Right. In the fourth one, when you plug in 4, which is approaching 4 from the left, you're getting a positive 1, and the right one is a negative 1, so it does not exist because the limits don't agree from both sides. And that is your final answer there. Good job. Okay, so